So this is my Visual Studio setup. So I will to show you how to create a new project. Just come in here and create a new project. But when you're selecting your project, it has to be in C++. You select C++ for Windows, then type an empty project. So you use an empty project to create project. So after you create the project, you have something like this. Under the source file, to create an assembly file, you come here and you add new item. So that you specify the name of the file .asm. .asm is the file extension for assembly files. Then for you to now specify include Ivan, the Ivan library. So when you come to this general, you see an item type. Make sure this is selected as Microsoft Macro Assembler. So that's the MASM that I've been talking about. Then when you come here, you now specify your include part, which is where you have your Ivan library. So I have downloaded Ivan on my PC. So if I come to download, so I've downloaded Ivan. So I've extracted it. I put it because this file is empty. There it is. So if you open the Ivan, you see the folder here, and these are all the Ivan lib.include etc. So I moved it into my local storage. Yeah, so you can see Ivan here. So that's what you import. Then all those other settings, I can just quickly go through that. If you come to build customization, you also make sure you select MASM. Then you also go to where is it? The properties. So under the properties and linker, you just go to this general. So in general, you also specify where your where is stored, your Ivan library is stored. Ivan. Then when you go to input, you specify the Ivan lib. Come here to edit, you see Ivan 32.lib. So and the last part you also check is your system. So your system, it has to be set to console. So I've done all this configuration already. So now this is an example of a Ivan code. Let's just some comments. So now I'm going to be solving this question. This question. So it's quite, let's see. It's not, let's see how it goes. So so the first line of this code is to initialize an array. So the array is containing values. But looking at this value, each of these values can can be contained in a byte. So a byte is 8 bits, and the maximum will be 255, which is 2 raised to the power 8 minus 1. So I can store it sequentially in memory as a byte. So an array of bytes. So that's the way I represent that int. Or if I still want to use int, I can now use it as probably what do you call it? Key int is unsigned. So we have multiple types. Under data, you can either use no, this is not part of the code. Let me comment. So data types, data types. So all these other aspect of the code is something you are familiar with. You have to first include ivan.in, include it, specify the architecture, the model. So I'm just leave it like this and allocate the stack memory. So the stack memory is having 4096 bytes, so about 4 kilobytes. So in the data, you can have data types as bytes, which is from 0 to 255 bytes. You can have it as a word. A word is a 16-bit value. So 16-bit value, that's 2 bytes. So the value will range from 0 to 65,535. Yeah. Then if it's a D word, that's a double word or a 32-bit number or a 4 byte value. So this one by default is unsigned. So it means that it's going to go from 0 up to 2 raised to power 32 minus 1. So that's for unsigned. I mean signed. No, sorry. Unsigned, that's to say it's only positive. But if you want it to be signed, that's from negative to positive, you use SD word. So that's for signed D word. So in the case of an int is by default a 32-bit number. So we can just say it's an SD word. So now, if I look at this code, what's the name of the code? Array. So I'm going to initialize that data as array. Let me give some time space. Array, which is a signed D word. So it's going to contain values. I can put them in their decimal form, which is 10, 60, 20 33 72, 20 33 72, um 89 45 65, 89 45 65, and 72 18, 72 18. So now I've created the value, the array of values. So, but I don't know the size of. I mean, I know when you store stuff in an array, it means that this array has point is a pointer to the first value. So all these ones are now contiguous in memory. That's to say they're now arranged side by side. So I have to have another variable tell me how many of them there are. So when I'm operating on it, I know that okay, I'll use that one to loop over 1, 2, 3, 4, etc. until I'm done with everything. So I think the array size is what's computed here using a size of array this. So there's a way to compute this though, but I'm not going to. Let me do that. So I'll first create this other variable which is sample equals to 50, and what sample is also is sd word sample. But since their values are never up to 255, I can still decide to use that as a byte, but I want it to like represent the int that they are specifying here. So um, sample, which is an sd word, is 50. Then this other value, which is array size, case Pascal casing, array size. That's the style of the variable. That I mean the word style of naming the variable. So for me to represent this actually. So what's in C++ or C? What this code means is that I want to get. I mean, what's the size of this guy, which is the entire array in bits. Then I will divide it by the size of a sample, which is the size of an int. So in this case now, if this is how many elements are here, this is 4, these are 10 elements. So the size of this array should be 320 bits, and the size of a sample, which is this 50, it should be 32. So 320 divided by 32 will give me the number of items in this array. So I can just hard code it as 10, or there's I can hard code it as 10, which is a good thing to do. Instead of me, I could also try to do the array the size after it then, but the variable have to be before sd word. So this dollar sign will tell me what's the current position in memory, like in the RAM, etc. The RAM position or something. What's the current position? Then I will now minus it with the pointer of the start, which is array. But that will give me the value in bytes. So I still have to divide this by 4. And dividing by 4 will have to be done inside the code. But I don't want to do that, I'll just hard code it. It should be 10. Okay, array size is 10. Then some initial values, which are index and sum. So these ones are going to be counters. Index is telling me where am I in the array, and sum what's the current like accumulation. So I think you just come here, you do index, which is also an sd word of no, all these things, if I change them to bytes, they're still going to have the same effect. So I don't know if bytes was the ones used by the lecturer, you can stick with that. So let me clean up this place. This code is just to define an exit process. So just memorize that. But even if this code is not there, but you will not be able to run it debug. Sure. Even if this code is not there, it will still work. So let me call the name of this code. Let me leave it like that first. I'll send it on WhatsApp number. So index is at initialized to 0, and sum is initialized to 0 also. So inside the code, I'm going to implement a loop, right? So the looping is say index. Let's use the code set. So while index is less than array size, so it's starting at 0, increment the index, then once index is already equal to the array size, which is like index is now 10, then you exit out of this loop. But nonetheless, if it's less than, you continue looping. So then you have a conditional, which is saying if array subscript, that's to say if the value in array, if the value inside this array at this position index is less is greater than sample. So it means that you're only summing up values in this array like that are greater than 50, like 72, 89, 65, and 72. So that's when you accumulate it to this variable. So let's see how to implement it. In assembly, we can make use of what we call labels. So labels, these are, I'll create a label now, which will tell me, okay, this main proc, which is a main process, that's like, call it a subroutine. So it's a main subroutine, or just like in C++, you have your main function. So yeah, then I'll declare a label which should be which should be repeat. Let me call it repeat. So I want to do my comparison before I even start running any code. So I'll check. For me to do comparison, I have to like store this index inside a register, which will be, I'll use the EAX register. Let me remove all this code. So let me remove this code first. So um, I'm going to do move into the EAX register. What am I going to be comparing now? I have two values I'm comparing. I'm comparing index to your array size. So I'm going to put in EAX index, and I'm going to move into, I'm going to use the EBX register. So I'm going to use array size. That's array size. So right now, let me place my PC very well. Array size. So though this way of getting this 10 is not too okay, so but I can probably I can leave it like that though. So but if you change the value, maybe like you add another value to this, you have to change the variable. So but I think I should be able to find a fix to that and send. The fix that comes to mind, I don't want to like do another computation later inside the code, but let's leave it like that for now. Then I've logged those two values, so I'm going to do a comparison operation. So CMP is for comparison, so I'm comparing from E to EAX and EBX. So after doing my comparison, if some flags in memory have been set, so I'm now going to have a jump operation. So I'm going to jump out of the loop. So I'm going to create a label down which will tell me the end. Let me call it break. So break now is a label. So if I jump to this break session, it means I'm going to end the code, because the next instruction will invoke exit process and end the subroutine, the main subroutine. So I'm going to do, it's only jump out of the loop when index is now equal to array size, because that's when it is going to be false, right? So but as long as it's not yet equal to, meaning that is less than, it should continue. So I can also make it greater than or equal to, but it's sure that it's going to catch it as equal to. So J is for equal to, greater than or equal to is, I mean, J is for equal to, yes, jump if equal to, while G is for jump greater than or equals to. So I'm going to leave it as JE, then I'm going to put the label it should jump to, which is break. So you should jump to break if that occurs. So that's, I've implemented this while part of the code. So the body of the code, let's say the body of the code, body. I'm just doing a comment for now. So at the end of running all the body of the code, I should jump back. This jump. So jump, this one will work irrespective of any comparison whatever. It should drop back to repeat. So it means that whatever I do here, it will repeat. It will repeat. It will go back to this place and do all these operations again. As long as this comparison has not ended. So in the first case, it will go 2, 3, 4, 5, 6, 7, up to 10. So inside this body, the first thing I want to do is that I want to do a comparison now. So the comparison should be, what am I comparing? What's in here and sample? What's in here and sample? So I'm going to move move to EAX. So to access what is inside an array, you use this. I mean, inside an array of values. So you use this array in square brackets. So this will give me what is at. Wait, I'm coming. I was just before the action. So yeah, for me to next thing I want to do is that I want to know, like I want to do this indexing. This indexing operation, you have to do some things to be loaded. So I want to first load into EX, which is my the accumulator register. So I want to load an offset value. This offset, what does it do? Offset will tell me the address of this first space in memory. So it's the address. What's the address of this first place? So that was to stay in EX. Then with index, this index value, I can now be able to identify where should I like search or where should I access. um, I'll demonstrate that. So the first thing I need to store in EX is the address of this first guy, and this is just how to do it. You move to EX, put offset beside it. Make sure there's no space between you than the command. Just stop it like this. EX offset. Then you specify the name of the variable that you want to get first as well. Even if it's a string, it's almost the same thing too. So though if it's a string, you use bytes because each character is stored with bytes. So when I move this into EX, then the next part is that I want to move into EBX. I'm going to use the other register to store index. You cannot just use the variables directly, so you have to load them into the register, do operations, then take it back to variables. So um, I'm going to move into EBX, which is the index. So the index. So now I can compute, I can find out what is array at index by doing this. So I'm still going to move it back to EX. EX is going to be my most used register. I'm going to move it. So now this is what I can do. I'll use this square bracket. So I'm going to put the address of where uh, where it's. So this stuff is going to help me look for it inside my RAM, inside the data memory. So EX is the register contains the address of the first guy. So I want to shift it by what's in EBX, which is the position. So if EBX is 0, you should give me this. If EBX is 1, you should give me this. If EBX is 3, you should give me this. If EBX is 9, you should give me this. Because you're using 0 indexing, right? So, but there's something. Assembly, x86 assembly uses 8-bit addressing. So it means that if I put 1, it's going to shift it by 8, but it's still going to be inside this because this one is a 32-bit number. I'm using a G word that is 32-bit. So I have to multiply it by 4 so that it will now be in, this will be 0, 4, 8, 12, just like that. Since each of them are spaced by 32 bits. So it's just as simple as doing times 4. So yeah, this is going to load into EAX. If the index is at 0, it will load 10 into EAX. The index is at 1, it will load 16 into EAX. Just like that, just like that, just like that. So now I'm going to do a comparison. So the comparison now will be between what is in EAX and sample. So I'm also going to load sample into the register. Move sample into no, move into EBX sample. So after I move EBX into sample, I'm going to do a comparison. So I'll compare EAX to EBX. So in comparing it, what should I do? If it's greater than sample, then I should add. So basically, I'm going to put, before I do the comparison, I'm going to put code to do this accumulation. So the accumulation here is that I'm going to load what's in sum. load into EX was inside sum. So initially sum will be 0. Then I'm going to now do add operation. Add to EX. So this add EX, then the value I'm going to put now will be um, oh, 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 oh. I've loaded this to EX. So let me do the accumulation. I'm thinking. So since I loaded sum into EX, that's already overwritten what was indexed for me. That's array at index, which I've loaded in this place. So I'm going to um, since I've done the comparison with EBX, let me do the comparison. So I should only do this operation of addition if it's greater than sample. But in the case where it's less than or equal to sample, I should skip it. So I'm going to do a jump operation here. It should be jump less than or equal to. So if I'm going to jump less than or equal to let me call the label don't let me call it skip. So skip should be after the addition. So what it's saying is that I'm comparing EX, which is the current value based on its index, and I'll compare it with EBX, which is sample, which I've declared initially as 50. So if it's less than or equal to, don't do this part. Just go to skip and you repeat. So don't do this part. That's just what it's trying to say. So this part now is what I'm going to resolve. So I'm going to store sum first into EAX. I mean, um, let me do the operation into EBX, so it doesn't matter. So I'm going to store sum into EBX, add into EBX, what's in EAX. So basically what it's trying to say is that this is the process of accumulation. So EBX will be equal to EBX plus EAX. Does it make sense? So it's the same thing as saying EBX, which was the previous sum plus what is array at index. So, and it's the same thing as just doing plus equal to. That's what I've implemented from C++ times this code. This was it in assembly. So I can leave it as that sharp. Then after storing it into EBX, adding and storing it, I will move into this variable, which is sum. I'm going to move into sum back. I'm going to move into sum EX. EBX. So EBX is the one that's carrying the new sum. So these have implemented that. So if it skips, it's going to not do this operation. But if it does the operation, that's to say it's greater than, then comes here. Then there's an operation that is left, which is index plus plus. So we can either do add for index, or I could use decrement. So I'm going to do move. I'm going to move. What do you call this thing? I'm going to move index into EAX. So I move index into EAX. Index into EAX. Then I'm going to. You can use ink. Ink means increment. So there's another way to do it, or you can do add with one. So I'm going to use ink. So it's just go straight. I've increment EX, and I'll move it back into index. So now I've ensured that at every point in the loop, index is increasing. So I'll move EX back into it. Then after that, I repeat. So it's almost done. Let's run it and see how it performs. So I'm going to use debugging, so I'll be able to see every step of the code. So I'm going to debug. So all these registers, you can still read more what those registers is. I think I saw a link that best explain it. So, well, it's quite all these ones. I know I make use of only data registers. I see some other registers like EBP, that's for base pointer, ESP, stack memory pointer, EIP, instruction pointer, what other ones have. And even the data registers, general purpose data registers, you can still break it down into AL, AH, BL, BH, just like that, just like that. Then, yeah, let me, so where down to put breakpoints. Let me put the breakpoint at this, this is where you click for breakpoints for me. So, so at every point in time, let me put breakpoint as repeat. So, let me put breakpoint as repeat. Then inside here, I'm gonna I will just monitor the values. There's a way to monitor it. So now let me run it. I've set up. There was build errors. Let me see errors. Missing after unary operator. That's at line 20. Okay. So I think why there was an error initially was that repeat itself is a keyword. So I make it not to be like a keyword by using an underscore in front. So I put an underscore to for skip, and repeat. You can think of another name, Sha. But I just prefer using this name. So I'm going to put some breakpoints. So now let me run this debugger. So now as I've run it, you can see these registers. They are initialized to some certain values. So I want to monitor some variables. So in this place down here, you can monitor variables. Let me zoom out on this. Awesome. So yeah, there's a variable that I want to monitor. The variable I want to monitor now is sum. I want to monitor sum. So initially sum is 0, right? So all these other variables I can get them deleted. Let me select them all first. I'll delete all of them. Delete what? So I'm going to continue. That's at every step. Let me see what sum is. So initially sum is still 0 because 10 plus this is not going to. And let me also put another value to watch, which will be index. I should watch index. So index is 1. So the index actually started at 0, but now it's 1. Let me run again. Index is 2 and 60 is already added to sum. So the next loop, 20 was skipped, but it's 3 now. You can see index is now 3. Then 4. Yeah, so 72 was added and it became 1. Yeah, 89 was added. 45 was skipped. 65 was added. So and the count is at 8 now. Then 9, which is 72. So at 10, the last one was not added. So I'm going to press play. So the program has ended. So I've solved the question actually. Yeah, but I think there's still ways to shorten the code, but this is a solution that works.